All right, so let's do the actual type checking. Finally we're able to do that. So let's make it some sort of like a separate state, I would say, right? So there is a generate, where is it? Generate NASM Linux x86-64, right? So here is the step that we're doing in here. So let me take a look. Yeah, there we go. And another step that we're going to have is basically type check program, right? Type check program. It will accept the program, right? So here's the program, and it's not going to return anything, right? It's simply going to meta evaluate the entire thing, right? So it's basically meta evaluation. So the way we're going to do that is essentially we're going to be I think we're going to be iterating, yeah, the same way as we actually do the compilation. So it's going to be IP, and we iterated the program, and then just test everything, right? All right, might be, yeah. So for IP in range length program, right? And OP is a program IP. Then we want to assert. So I think I'm going to start copy pasting this entire stuff. So exhaustive operation handling in type check thingy. There we go. Type check program. Type check program. So if OP type. So I need to actually grab the all of the OP types that we have in here. There we go. So can I do something? Why it only did that partially? Emacs, what are you doing, Emacs? Okay, so this is the auto, and maybe we're ready to do a little bit of a Emacs magic, right? Like so. If, maybe elif OP type equal to that, and okay, what I want you to do is to do assert false, not implemented. All right, thank you, Emacs, very cool. All right, hopefully, well, it doesn't want to put it in here for whatever reason. Right, so this is going to be that. Then it's going to be that, and then it's going to be that, and here we're going to have something like unreachable, right? False, unreachable. There we go. So that's pretty cool. One of the things we can do now, if we encounter int, what we're doing, we need to push integer onto the stack. If we encounter string, we have to push two things: integer and pointer. For intrinsics, we have to do a separate thing as well. So let me see. So where is the intrinsic? So we'll have to check that we're handling all of the intrinsics exhaustively, right? That's very important. There's 33 intrinsics in here. So, and this one is a type, oh my god, I can't see shit in this mist. Type check program. Okay, so let me go to intrinsics. Intrinsics, here are the intrinsic, and this time I'm gonna use a different approach to auto-generating code in Emacs, right? So first thing I wanna do, I probably wanna replace auto with just colon, there we go. And maybe I want to replace 1, 2, 3, 4 with 1, 2, wait a second, 1, 2, 3, 4, 1, 2, 3, 4, elif space, there we go. So we have something like this, and maybe not. So I think it should be something like OP, is it OP? I think it's OP operand. There we go, so that looks a little bit better. And now this one is going to be something like this. So in here I might do 1, 2, 3, 4, assert false not implemented. Right, so this one is not implemented, and I want to copy paste all of them between those things. So maybe I'm going to use a little bit of a Emacs magic as well, like so. Almost there. So Should have copy pasted it like this. One more time. Yep. So this is gonna be like that, and in here we're gonna do else assert false unreachable. There we go. So we've got some code that we can finally copy paste. Cool. Type check. Okay, so it kind of almost worked. It almost worked. I just have to do this thing where I add 8 spaces in here. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Cool. So we have a stub for all of these things in here. That's pretty cool. So we do type check. And I guess that's it. I guess that is literally it. So we can just try to do the test and see if it's going to work. It does work, and the reason why it works is because we never actually call this function anywhere. So I also want to kind of check the type check the Porth program just to see if I didn't screw anything up. So push int is not. God fucking damn it. Okay. So I should have actually put OP type in front of all of these things. Yeah. So this is OP type. This one is an intrinsic. This is that. There we go. And this one is going to be intrinsic. Okay, so maybe I can even do something like this. Excuse me. It's kind of dangerous to actually go too much with multi-lines, because it may go into some other functions that I didn't mean to go. Though we can do something like query replace op operand equals space, and then op operand equals intrinsic, and just do it like that, so we have a little bit more control over how we replace things, and we can stop at any point. This is precisely what I meant in here. And let me see if everything's fine. Everything's fine now. It's pretty cool. So it's pretty cool to have some sort of like a static type checking in Python, and that's the reason why I'm implementing that for Porth, right? Because it's proven to be useful for Python, so it is useful for Porth as well. So, okay, now what we want to do? We want to do type check before we try to simulate the program or compile the program, right? So let's go here. As you can see, we're generating the program. But before generating program, let's go ahead and type check this program, right? So we're going to do it like that. So this is the generation, and let's take a look at the simulation. And before simulating the program, let's type check it. There we go. So there's two steps in here. We're reading everything, we compile a file to a program, then type check program, and then either simulate or generate x86-64 code. Right, so it's basically an additional step, right? We don't modify any of these phases, we just slap an additional step in here. And now, if I try to maybe have a very simple program in here that simply adds two numbers, 34 and 35, adds them together and prints that, it should fail and it should not pass the type checks phase, right? So let's do simulate full Porth, and as you can see, it's not implemented. So push int is not implemented. How are we going to implement a push int? So we're going to maintain a stack, right? We're going to maintain a stack. Essentially, instead of pushing a specific number onto the stack, we're going to push a type. Right, we're going to push something like integer, though it would be better to maybe have enumeration for the types. All right, so let's actually have type, which is going to be int enumeration, and we're going to have something like int, right? And in here, we're going to simply append type int, and there we go, this entire thing is implemented. So, and in here we can say that this is going to be a list of types. This is a list of types. Okay, cool. So now let's try to recompile it again, and int enum, is it not available? Is it enum int? Oh, I see. I probably never actually imported it because I never committed the profile that I implemented in one of the videos. Int is not defined, so let's do auto. There we go. So now it complains about the plus. It complains about the plus, and this is actually super cool. Okay, so if stack length is less than 2, if it's less than 2, we're ready to print an error. So we're already starting to write as useful code that will help us in the long term, right? So how we're going to be doing all of that? So this is going to be the path, then the row, then the column, then the error. Not enough arguments for the plus intrinsic. And we have to put a location in here, and we're going to take a location from the operands. So this is the location. So, and also a file is going to be the std error. And after that, I'm going to just exit with 1. There we go. So after that, what do we do? So now it complains about print. Print is very interesting. I think print, it's supposed to print any value, right? It doesn't care. So in the thing here, we're going to do if, oh shit, I forgot. I need to actually, essentially, yeah, let's put a cert in here. It's not implemented yet. Let's go back, right? Because now I need to get the types of the elements. So I'm going to do stack pop, and then stack pop again. And if a is not equal to type integer, we have to complain that you're trying to push not an integer in there, right? So, but it would be nice to actually say that here this element is not an integer, but we don't know its location. And this is kind of a problem. So let's actually have type and tuple, type and location, right? And when we push things in here, we're going to have int and op location. So we keep track not only the types of the things we push in the stack, but also their locations, so we can use them in error reporting. I remember. Always remember. Happy day. Okay, so I'm just reading the chat, I'm sorry. I do realize that without the chat, the context is actually unclear, but I'm just, you know, sometimes I'm reading the chat and people are memeing in there. And I'm just memeing back, so that's what I'm doing. All right, so we have a stack, and we have something like it's a A type, so this is a type and a location, right? So then B type and B location. So, and if a type is not equal to integer, we're gonna say this thing is expected to be an integer, right? Error, first argument of the plus intrinsic is, ooh, you know what? It would be better to have like a human readable representation of this thing, but I'm gonna fix that a little bit later. Okay, so to do, use human readable representation of intrinsics in error reporting. Right, so I'm gonna do that a little bit later. So first argument is expected to be int. Right, and here we can do the location, and we're going to use the location of a lock, and the file is going to be sys std error, and then we're going to exit with 1. There we go. So I'm going to do the same thing for b, right? So this is going to be a, replace it with b. There we go. I can't see shit in this mist. And then we have to put back, we need to append a type back, so it's going to be type integer, but now we're going to use the location of the plus operation, indicating that that value was provided by the plus. So that's actually pretty cool. There we go. So yeah, we implemented type checking for the plus intrinsic. So as you can see, so now we check a lot of these things. Wait, is I cannot see shit in this mist some kind of a reference? Yes, it's a old Forcing meme. So, yeah. It is in fact a reference. Okay, so we have if in here, and now when I do print, essentially I don't really care what's on the stack, right? So if len length of the stack is less than 1, we need to print something like to s d d error, not enough arguments for the print intrinsic. There we go. So, and we're gonna do something like op lock sys file sys std error, and this one is gonna be exit 1, and in here I'm gonna simply just do pop, right? So this is gonna be pop. And there we go, we have 69. And now let's actually try the other things. So what if I don't have enough arguments for this thing? So what is it going to say? Not enough arguments for the plus intrinsic, and there we go, so it shows plus. This code doesn't fucking compile. If you do something like this, this will not compile. It's already useful, it's already more useful than it was before. This is actually very cool. Right, so and if you do something like this, there we go, so it will print. Interestingly, if you try to drop, this one is really cool. So right now drop is not implemented, so let's go ahead and implement the drop, right? So how are we going to be implementing the drop? If len stack is less than 1, not enough arguments for these things. So we're going to do a lot of copy paste in here. Not enough arguments for the drop intrinsic. So we're going to exit, and in here is going to be stack pop. It's actually literally the same as print. In terms of type checking, it's literally the same as print. But now it says not enough arguments for the print intrinsic. You see, you dropped it, and now there's not enough arguments. All of that is checked at compile time, and you don't even have to like execute anything. So it's already like type checked and stuff. But there's another interesting thing. I also want to prevent these situations when you have trailing stuff on the stack, right? You see, you summed up two things, but you forgot to print that. So you forgot to handle the rest of the data. So, and that could be an error, actually. That could be an error. And I also want to throw an exception when something like that happens. So let's go ahead and do that. After we did all of the type checking, we can check the current state of the stack, right? If length of the stack not equals 0, there is something on the stack, right? So print s d error. What we're gonna say in here, unhandled data on the stack, right? And the location is gonna be somewhere stack pop, and I think it's the second one, right? So it's located somewhere here. So maybe I'm gonna do something like, yeah, it's fine. I guess I can do it like that. And file sys std error. And then we're gonna exit with 1. There we go. So there we go. Unhandled data on the stack, and it points at plus. So now the only way to make this thing compile is to handle everything. So you can do print, or you can do drop, right? You can do drop. But if you do print after the drop, there is not enough arguments for the print intrinsic, so you have to remove the drop. This is actually a very simple way of type checking everything, but it goes a very long way. Right, it catches so many different errors. It's insane. It's absolutely beautiful. I really love it. So it is very, very fucking cool. So interestingly enough, so here we also checking different types and whatnot, right? We're also checking different types, and I want to do an assertion in here, indicating that here we're expecting. So len type, so the amount of types we expect in here is going to be 1. Exhaustive type handling in plus intrinsic. There we go. So exhaustive type handling in plus intrinsic. Because if we add new type, I think I want to handle that properly, right? So for instance, we can sum up integer and integer, but I also want to introduce a type called pointer, right? And for instance, I want to not allow to be able to add pointer plus pointer, because that doesn't make any sense. Right, I only want to allow operations like pointer plus integer, which results in a pointer, and also integer plus pointer. That way, well, yeah, this is the only valid operation that you can do. And also, you cannot multiply pointer by pointer or by integer, because again, it also doesn't make any sense. Right, the only valid operation is going to be pointer plus integer, which gives you a pointer, and that way you can do safe pointer arithmetics, more or less. Pointer minus pointer is also actually good, right? So pointer plus pointer doesn't make any sense. Pointer minus pointer does make sense. Thank you so much for the heads up. So you see, I want to like have these kind of types and do these kind of checks that can catch, you know, unintentional things. So that's gonna be the idea. And for instance, push string pushes two things. It pushes integer and pointer. Right, so a single string literal pushes two things, and I want to check everything appropriately. So, yeah. Essentially. Though, it would be also nice to type check syscalls, but in case of a syscalls, it's kind of difficult to type check them, so we'll have to think how to properly do that. But in any case, so that's pretty poug. This seems like it does more than type checking. Well, so far we only check the types, to be fair. We don't really do anything but type checking here. So, I don't know. So that seems to be it. Alright, so let's see. I want to implement a push string. So let's go ahead and do that. So let's try to simulate a hello world, right? So we have example and let's do hello world. Okay, so we don't have implemented one things, push str. All right, so what I'm gonna append in here, I'm gonna append type integer, op lock, and type pointer, op lock. There we go. So push integer pushes only integer, but push string actually pushes integer and pointer. That's cool. Alright, so we also have not implemented syscall 3. Alright, so for the syscall, I think, I don't even know. I guess for all the syscalls, well, there's one thing we can do for the syscall, right? Oh yeah, that's definitely, we need to check the length of the stack, and it has to be, if it's less than 3, right, we can say something like, yeah, this is already useful, even though we cannot type check the specific arguments of the syscall, right, we still can check the amount of arguments, right? So for the syscall 0, it has to be 0, 1, 2, 3, and so on and so forth. That makes a lot of sense. Okay, I really like that. All right, not enough arguments for syscall 3 intrinsic. Right, so, and this one is going to be op location, location file sysstd error, and here we're going to do exit 1. Right, and in here what we want to do, we want to pop 3 arguments, so this is going to be stack pop. How many times? We want to do that 3 times, so maybe I'm going to do that in a loop. In range 3, so we'll do that 3 times, and we need to push back something. So for now, I think we're going to push back type integer, right? So I think that makes sense. Type integer, and location is going to be op location. Right, I wanted to actually introduce a new type called code, but some syscalls don't return codes. Some of them return numbers, right? For example, write returns how many characters you wrote to the file. So, would syscall tree not need 4 arguments? Oh shit! Yeah, it needs 4 arguments. because it also needs the, yeah, it needs 4 of them. Thank you so much. Yeah, there should be 4 of them. So now let's do a little bit of a copy pasting. So I'm gonna do something like to do, figure out how to type check syscall arguments, right? So yeah, how to type check syscall arguments and return types. Yeah, so this would be useful. Okay, so the rest of the stuff is just copy paste. Witard, WT3, I don't know how to pronounce the nickname, but thank you so much for how many? For 10 tier 1 subs, right? So it's gonna go for a while, and everyone who got the sub, welcome to our epic Zotin community. So does everyone have any questions maybe while we're waiting for this thing to finish? So what are you working on? I'm working on my own programming language and compiler for my programming language. You can find this thing in the chat. Do a project command. And another gift from Anonymous to Cellophane11578. Thank you so much for the gift. So let me see. I think control flow would be tricky to implement. We're going to implement control flow the same way it is implemented in WebAssembly Validation. So I really recommend to read this article about WebAssembly Validation because they do a similar thing and they do handle control flow. Right. So, and they do like a couple of trade-offs to make it work. For instance, in case of loops, rather not loops, but blocks, the stack cannot underflow or overflow within the block. So this is one of the things you're not allowed to do, and it kind of like makes it work. So yeah. When a macro is expanded, is loc the location where a user used that macro? No, loc is location of the token within the definition. I can actually show you. So just a second. One of the things we need to do, we need to disable the type checking. So let's disable the type checking. There we go. So let's imagine that we have a macro, foo, that uses non-existent operations, right? So something like percent, well, we do have percent dollar, right? We don't have a dollar. And then I do something like foo, right? So as you can see, the compilation will fail within the macro, right? And if I do something like porth simulate foo porth, it will complain that we have a known word. And if we go there, it will go to this specific thing. So location for that token is going to be where it's defined. What is your programming language going to be used for? It's going to be used for writing software. So that's my plan. If it is included, even if it is included, so we can put that in somewhere in bar. Right, so this is going to be bar porth. Right, so this is going to be like that, and I'm going to just include bar porth. Right, so we have 2 files, right? And if I do this thing one more time, as you can see, it complains about bar.porth, and it will redirect you here. So if you have an unknown word, it will tell you where that specific word is used. So it keeps track of all of these things. Alrighty, so looks like everything's fine, and let's continue working on this entire thing. Okay, thank you for all the subs and all the questions, really appreciate them. Okay, let's enable back the type checking, type check, there we go, and let me see. So, All right. So foo Porth, right? And I want to do, yeah, I want you to actually do the hello world in here, right? I want you to do hello world. So this one is going to be example hello world.porth. There we go. So what we're trying to push in here, well, you cannot push in here, so this is append. Syscall 3. Okay, so what I want you to do before the gifts to the subs, I want you to copy paste a bunch of code, right? So here we have 1, right? So this is 1. Another one we have in here is 2. Yep. And this one is going to be oh my god, it's really not convenient to copy paste like so. And this is going to be 3. Though maybe I don't have to do that for all of the syscalls right now, because not all of the syscalls right now are used, so we can always implement that later. So doesn't matter. So this one is going to be 0. This one is going to be 1. This one, oh my god, Emacs, why are you so annoying? And this one is going to be 3. Okay, so if I try to do that and highlight data on the stack, oh shit, this is so goddamn cool. All right, so yeah, as you can see, it complains about unhandled data on the stack, though it's not particularly useful. Right, but yeah, it complains about the thing that we was talking about for quite some time already. All right, so you need to drop this thing first or handle it. Right, so you're kind of forced to handle it, and now it will print hello world. What's funny is that if you swap this thing around, yeah, now we have, okay, swap is interesting as well. It's not gonna be that useful, I think, because these syscalls don't type check at all, so it doesn't matter. Yeah, okay, so that's totally fine. At least now hello world compiles, which is nice, so that's pretty cool. So maybe we should start working on some more interesting problems, like this one, like type checking this thing. I think that will be useful. So let's try to make this thing compile and see how it goes. Okay. Oh boy. So sequence 100. So this is going to be Porth. Okay. So what we don't have implemented? While. So I think while doesn't really matter. Right. So because while serves as a point to which you have to jump when you need to repeat the thing. So yeah, I think it doesn't matter. So while is going to be just this, right? It's going to be pass. So we're going to simply ignore it. So another thing we need to implement over. Okay, this one is interesting. We need at least 2 arguments to implement over. Right, so it's going to be stack. If it's less than 2, not enough arguments for the drop intrinsic. For the over intrinsic. Okay. So then we need to do the following thing. So we pop a stack pop. Right. So we had something like BA. So we've got A. Then, so maybe I can actually keep it as a temporary in here. So we got A. Then I can probably duplicate this thing. Maybe not, I don't know. Let's do B as well. So this is going to be stack B. Right. Then I want to push it back. Stack append B back. Then I can push A back. Right, I push A back. So this is going to be A. And then I want to push B back as well. Right. There we go. So this is what we're going to be doing. So we had BA and yep. So that's essentially what we're going to have in here. So that's what over does. So the next thing is greater. Oh, greater is interesting because we have an opportunity to finally introduce another type, right? So, and the next type is going to be Boolean, right? So greater will accept integers and it will push a Boolean on the stack, and ifs and whiles will only accept Booleans. So that's what we're going to have in here. Isn't that cool? Right. So we're going to have like a proper type checking. So some operations consume one types, the others consume another types. Alrighty. So we have a Boolean in here. So, and basically the entire process is just trying to compile different programs and implementing the unimplemented intrinsics or operations. So what's interesting is that a similar approach people use for implementing emulators and virtual machines, right? So if you watch any like a Game Boy emulator implementation video, people just take all of the instructions, right, and just make a switch case, and if it encounters a known instruction, it basically breaks, and then they take the game and they constantly run the game in an emulator, and if it fails with a known instruction, they implement an instruction, then they run it again, implement the next one, and so on and so forth. We're kind of doing a similar thing, right? So we're implementing type checker, we stop all of the unknown things with not implemented, and if we encounter a known thing, we implement it and keep trying to compile programs until they compile and until we implemented everything. So we kind of implemented an emulator for the type checking, if that makes any sense. So yep, pretty straightforward process. I did it in that way in my chip 8. Yeah, so that's a pretty straightforward way of doing that. It's actually because you sort of go into this flow, into this well-defined process. You just run it again and just see what needs to be implemented. It's pretty straightforward. All right. Okay, let's continue. So not implemented GT. All right, so if len of the stack is less than 2, not enough arguments. So as you can see, I'm just copy pasting shit at this point for GT intrinsic, right? So then I'm going to do A, B. So on the stack here we have B and A. Stack pop, and then B stack pop. So and in here less, I suppose it makes sense if A and B are integers, right? So here we're going to have A type, so here's A type and A location, then B type and B location. So this kind of thing is allowed when A type equal type int and B type equal type int, right? Type int. In that case, what we're doing is essentially pushing type boolean onto the stack at a particular location. Else if A type equal type ptr and B type equal type ptr, and in that case we also push boolean. Otherwise we have to throw an error saying that the argument is expected to be something else. All right. So maybe we can write that slightly differently, but I feel like it will overcomplicate this situation, if you know what I'm talking about. So you can always write it like that. If A type is equal B type and A type equal type int or a type equal type pointer, right? You can always compress that, but I'm just a little bit afraid that it will make it more difficult to append operations on the stack. I don't know. Let's keep it like that. I think it's fine. I think it's kind of fine in here. Right, so, and in here we're gonna print an error saying something like invalid argument for invalid argument type for GT intrinsic, right? For GT intrinsic, and we provide the location, and we also print into a file. Can I just do something? I just want to make it a little bit bigger, but I cannot see shit. So system std error, and then I want to do that. Okay, so the file for the Porth becomes really big, and the Emacs becomes very slow because of that. I don't know, I should switch from Emacs to something else. Okay, so what do we have in here? Yet again, this is not push, this is append, and the next operation that we need to implement, we need to implement do. Do is very interesting. Do is extremely interesting. So essentially, so it would just expect a single boolean, right? So do is supposed to expect a single boolean, which makes it rather interesting, I'm gonna say. All right. So if stack, if len stack is less than 1, not enough. Not enough arguments for do operation. So this is the location, and I'm just gonna quit. Then we take stack pop, right? We do stack pop. So this is gonna be a type and a location. And if a type is not equal type boolean, right? It has to be boolean. We're gonna print something like this: sdd error do operation expects bool argument. Right? So this is gonna be something like that. And do I care? So let's actually put log. File sys std error, and then we're gonna just quit the entire thing. There we go. All right, so the next thing that is not implemented is a duplicate. Okay. We're going to need casting. Yes, it is true. We'll need to be able to cast things. That's for sure. Because in some of the places I do use integer as boolean to make things a little bit easier. And we want to allow the user to do the things that they know they're doing, right? So we want to be able to cast booleans to integers, integers to booleans, and pointers to integers, integers to pointers, and so on and so forth. But it has to be explicit. Did you need to pop the stack for do? Yes, do does in fact pop the stack. All right. So so the next thing we need to implement, the dupe, right? Dupe, not enough for print. This is dupe, and in here I'm gonna do stack pop, and then I do stack push, right? And I just push it back. Okay. Next one, next append. Keep forgetting that it's append. All right. Okay, that's pretty cool. So now we have a plus operation, and in here, as you can see, we only allow plus for integers, right? We only allow plus for integers. And this is where it becomes kind of interesting. So what I want to do is essentially I want to pop these two things. If a type equal type int and b type equal type int, right? So I want to do, I want to allow this kind of situation, right? So in that case, it's going to be stack append type int, right? It's type int and location is going to be op location. There we go. Otherwise, if a type equal type int and b type equal type pointer, right? Equal type pointer, we're gonna append type pointer. Now the other way around, pointer integer pointer. Anything else is illegal. Right now, integer, 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 integer pointer, 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 integer, pointer. Anything else, forbidden. Okay. So the way we're gonna report that is probably gonna be super simple. SDD error invalid argument types for plus intrinsic. So and we can put something like S and S. And the first one is going to be A type and B type, right? So A type and B type. Though, yeah, it's fine. It's totally fine. And here we're also going to have something like location, right? So it has to be location plus. And after that, file sees std error, and we're going to exit with 1. Okay. Cool. So, and now we handled how many types? Now we know how to handle 3 types. Right. So it's only integer, 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 pointer, pointer, integer. All right. So what else do we have in here? Did I? Yeah, I managed it. It's supposed to do this thing. So what's the next thing? And, okay, this one is interesting. And is not implemented. So we only want to implement the end that closes while. As far as I know, you can easily know what exactly end closes by looking at what it points to, right? So, oh shit, this one is interesting actually. So yeah, this one could be a little bit tricky to implement. So this one could be a bit tricky to implement. So let me think. One way we do that, we take the program and just do op operand, and we just use this operand as the address. And if the type of this thing is equal op type, we like type while, we know that it's a while. All right. So. Yeah. So I'm thinking that we need to have a way to indicate that you're not allowed to sort of underflow or overflow. We need some sort of a stopper. We need some sort of a stopper at the at the stack. So this is very interesting actually. So let me show you. So we have the block while, right, then some sort of condition, do, then the code, and end. So before the do, we evaluate operations and we have some shit on the stack, right? We have some shit on the stack. As we encounter while, we have to put a special element that sort of blocks the stack. So that means you can never go below that element. You can copy the elements below that mark, but you can never like pop and remove elements below that mark. And as we have this thing in here, we evaluate the condition, right, and then evaluate the body. And if anywhere during evaluation we encounter this like stopper, we throw an exception saying that you're trying to underflow the block or whatever, right? And when we encounter end, we only expect to see this stopper. And if we don't see that stopper, that means at the end of the iteration we have an extra element on top of the stack, and that means on the next iteration we're going to have more and more and more, and the stack is going to grow. So, and this is essentially the limitation that Wasm also puts on the program, and I think we can implement it with a special like stopper element. What if we use a loop to produce multiple values to be left on the stack to be consumed later? Well, I'm sorry, too bad. You cannot do that in Wasm either. So you can, if you want to produce several elements for consumption later, you can put them into the memory, right? So on top of the stack, you also have a memory. You can just put them in the memory, and after the loop, you can extract them from the memory. All right, so that's the thing we want to do, but I feel like I want to do that next time, because I'm already streaming for quite some time. Refactoring arguments actually took more time than I expected, and I just wanted to demonstrate the gist of the type checking that I'm going to introduce into the language. Right, so yeah, so I guess I'm going to finish this entire thing off screen, right? Because what it requires is just like routinely going through the unimplemented operations and just implementing them, right? So, and that's going to be the gist of the type checking for this language. And again, I want to implement it before I go into self-hosting, because the lack of type checking always makes me introduce all of these stupid mistakes, man. So yeah, I think it's quite important. All right, so that's gonna be it for today. Does anyone have any questions? It's not really useful to leave arbitrary numbers of values on the stack after a loop because you can't read them. Yeah, I guess. So again, if the loop produces several values, just put them in the memory. There is a way to just read and write into the memory sequentially, just like in any normal language, like in C. So just put it there. You can always circumvent these limitations. So next will be casting. I suppose, I'm not really sure if we need the casting, but we'll see. So what else do we have in here? Dupe should append twice. Didn't it append twice? Wait a second. Yeah, I think it should append twice. Thank you so much. It is appending twice now. Alright, so since there's no question, I guess I gotta go. So we have initial code for the type checking, and I'll see what we can implement next time. Alright, that's it for the day. Thanks everyone for watching. I really appreciate it. Thank you for all of the subscriptions and all of the donations. I really appreciate that as well. And yeah, check all of the links in the description if you're watching on YouTube. Check the source code of the project in here. And I gotta go. So should we rate somebody? I don't know. Does anyone streaming anything interesting on the software development section of Twitch? I wish my computer was a bit faster for such a simple website as Twitch. But as always, Twitch is not a simple website. It's complicated. Look at all of the elements in here. No one is streaming. I don't know. I didn't see anyone is streaming. All right. Okay, that's it for today. Thanks everyone for watching. Love you.